it's okay. Yeah, you got this.
Thank you.
Yeah.
Alright guys, let's see how we can do question 1. Question 1 is, there's a typo in the question. I mean, the confidence interval should read like this. It should read like z to 1 minus alpha by 2, not alpha by 2, times the standard error, which is right. This is the confidence interval in question 1. Okay. The first part is to find the width. Now, obviously, the width of this interval is just 2 times this, right? So it's going to be 2 times this, and this is clearly proportional to the standard error. Okay. That's part 1. Part 2 is asking you to draw the graph of I'm sure you guys know how to graph functions. I mean, in calculus and vectors you did learn about how to graph functions, so this must be a piece of cake, I guess, for you. I mean, to graph a function, you need to first find the point. So v at 0 is 0, v at 1 is 0. The first derivative, what's the first derivative of this? It's gonna be 1 minus 2p, yeah, which is, can take 3 different values. It can be negative, it can be equal to 0, it can be positive. It can be negative if what? If p is between 0 and half, and is 0 if p equal to half, and is positive if okay. Alright, and we also know that the v double prime is minus 2, which is a negative number. So the graph, given all this, you should be able to draw the graph of v of p, right? Okay. So given all this, so you should draw suppose this is 0, suppose this is 1, suppose this is half. The graph will look like, what would it look like? It would look like this. It will have a maximum at p equal to half, and the value at p equal to half is a quarter. Right? They're clear, guys. I mean, this is stuff you must have done in your calculus course, right? It's easy. It must be. Yeah. All right. Now that's part 2. Part 3. For part 3 of question 1, is just find the upper bound for the width. Right, the width, as I said before, is 2 times 1. Okay, 95%. It means z 0.975 times p n is 1000, right? So this is the width, right? And we just showed that p times 1 minus p, looking at the graph, must be less than or equal to quarter for all p. So this is bounded above by okay. Are you guys okay with this? So because the whole graph is bounded above by quarter, so this is bounded above by 1/4000. Okay. You can do question 2, please. Question 2. You guys okay with that? Any questions you want? If you don't follow that, just please ask them now. You guys okay? Question 2. Question 2. Just numbers. Question 2 is on numbers. So let me to help you to do question 2. Let me put a sheet. You guys probably remember this from last week. These are the two-sided confidence intervals that we did last week. You may recall, and they're very complicated. This is the two-sided CI for mu1 minus mu2 when the variances are known. This is when the variances are unknown but equal, and this is the one when the variances are unknown and not equal. And this is for the difference in proportion. So to do question 2, you need to use one of these formulas. So I'll put it here, and to think about, you will need to use some of these formulas to do question 2. Hello. How are you? Where's your friend? He's always playing football. How is it? How are you? This is your report?
Yeah.
So you can start with- You guys okay? you guys worked out how to use which one you think applies to question 2? There are 3 formulas here. This is the formula when the variances are known. This is when the variances are unknown but equal, and this is when variances are unknown and not equal. So let's see which one for question 2. So let's take this away. So what you're given is the following. The first sample is of size 150. The sample mean is 1386. The sample standard deviation is 114, which means, remember the sample standard deviation is simply this one. Sorry, n. This is 11114, right? And the second sample is of size 200. The sample mean is 1218, and the sample standard deviation is equal to 98, and we are looking for a 95% confidence interval. So that means 100 times 1 minus alpha is 95. So that implies that alpha is 0.05. Right. The first part is assuming that the variances are not equal. So which formula you think we should apply? Of the 3 I've shown you here, which one applies? Is it first, number 1, number 2, or number 3? Huh? Come on guys, wake up. Come on guys. These are the 3 formulas I just showed you a minute ago. I just showed you these formulas, right? The first one is when the variances are known. The second one, variances are unknown but equal. The third one, the variances are unknown and not equal. So which one, for number 1, which one applies? Can you talk to me, please? Now what we know here, guys, this and this are sample standard deviation. They are not population variances. We don't know the population. The question does not give the population variance. So the one that applies here is number 3, x bar, which is yeah. How come you look lost, guys, some of you? I know this material will not be examinable though. I'm just doing an example just because I taught you. But don't worry, this will not turn up in the exam. Right? I mean, each of these guys here, this guy here, M, N, everything is given to you over here. All right? All you have to is just plug it in. I'm sure you can do it. You should have a calculator. I don't have one. And A, by the way, A is a number that I defined in the. I haven't written it. I haven't got it here, but it's a pretty nasty expression I gave you guys. Do you remember that from last week? No. The expression for A, the expression for this guy here is like half a page long. I don't know. I gave it to you in the scan notes, and it's also in the printed notes. But I don't expect, and I don't want to write it down here because it would take me half a day to write this down, right? So the expression for A is given in the printed or the scan notes, and you can find it, right? Okay, all right. That's part one. Part two. For part two, right, of question 2, we are assuming that the variances are equal. So the formula to use is, once again, to this formula sheet. The formula to use, it will be which one? Will be this one, right? Because we are assuming that the variances are equal but unknown, right? So you'll be using this one, right? So it will be m plus n minus 2 is 350, 348, 0.975. You can read this from the table. You guys have the table in front of you. You can read this, right? If you don't have a table in front of you, let me know. Okay, you should be able to read this. And multiplied by this nasty expression. Once again, you know what each of these guys is equal to, right? Because you should go to the beginning of this sheet. Here we have all the data. Also, all you have to do is just sub in all the data for this one, m and the n, and you get it, right? And of course, I'm not going to do it, but you should have time. You can sub in all the data for this, and read this from the table in front of you. You have the confidence in it. Yeah. Right. All right. That's question 2, guys. Now, question 3, please. 3. Hello, sorry. Yeah. Just type help. If you type help case test, it will tell you what code. Yeah, but can I show you? So if you want case test for, like, suppose your data is in X, right? Suppose you want to test for normality, then you say P norm. So P norm, N-O-R-M, okay? That's going to be false, a big false, okay? Then comma, then you will put the 2 parameters of the normal distribution, which is mean and the standard deviation. So it should be comma, the value for the mean and the value for the standard deviation. You should type this in. It should give you a p value. And if that p value is greater than 0.05, then that's a good effect. Otherwise, it's not. Right? So, This is still a matter. So
So
this is the way to test for the similar for the other distribution. For that you should look at one of the lab sheets.
Is it on there?
Yeah, if you look at one of the I think it's the third and fourth one. It shows you how to superimpose the PDF on top of this program. Yeah. If you can't find it, just email me. I will show you why it is exactly. Yeah. Alright. You guys okay? And you do question 3, please. Question 3. Do question 3, please.
Is that what you think?
Yeah.
Alright, let's see. Guys, have you done question 3, guys? Right? Guys, you listening to me or what? So you have a random sample from this, so the sample mean should have this distribution, and you have another random sample, so the sample mean should have this distribution, right? And the estimator that we have for mu is something like n this is the estimator for mu, and we want to show it is unbiased for mu. So what do we need to show? To show that is something is unbiased. No? You guys forgot to know what? I mean, I did 10 examples on this, guys. I remember doing 10 examples. You need to show that the bias is equal to 0, right? Okay, so you need to show that the bias of this, which is the expectation of okay, which is equal to 1 over n plus n right, and we need to show that. Now we know that we know from above here that the expectation of x bar is mu, and similarly this is also mu, and this is clearly equal to 0, right? So what we have shown that mu hat we have shown that mu hat is unbiased for mu. Right, that's the first part. The second part is to show that guys, is this clear to you, all of you? This part here. You guess okay? Yeah. Yeah. The second part is to show that this guy here is unbiased for sigma squared. Now the Sx squared is the sample variance for the first sample, Sy squared is the sample variance for the second sample. So you can write this using the definitions I gave you in the class for the sample variance. Right, this is, you can write this like this, okay? Right, now we need to show that the bias of this is 0, right? That's what I'm going to do now. So let me put this a bit up. we want to show that the bias of this guy here is 0, right? So remember, the bias is the expectation of this guy here, which is minus sigma squared, right? Now taking the expectation inside, you can write it as right. Okay, now let me remove this. Now we need to simplify this. Now this is where the thing that we learned comes in, right? What I'm going to do is the following. I'm going to rewrite right. Okay, now let me check your memory. Do you know something about this and this? We learned this in the class some time ago. What do you know about this, guys? Yes. Yes, exactly. So you have. So what you have is the expectation of a chi-squared variable with n-1 degree of freedom plus the expectation of a chi-squared variable with n-1 degree of freedom minus sigma squared. Right? Now, one thing I proved in the class is that the expected value of a chi-squared is equal to the degree of freedom. So this thing here is n-1 and this thing here is m-1, right? So you get n-1 plus m-1 minus sigma squared, which is of course equal to 0. So hence we have shown that unbiased for sigma squared, right? Right, now the next part of question 3, there's one more part, is to find the variance of mu hat. You guys okay with this? Yeah? Yeah, to find the variance of mu hat, it's not difficult. Right, you have the variance of n x bar plus m y bar divided by n plus m. Alright, take the variance inside, you get this to be right, and then you have n squared times the variance of x bar plus m squared times the variance of y bar. Yeah. Okay, so you should take the variance. This is now we know from what I mentioned a couple of slides ago, we know the distribution of x bar and the distribution of y bar, right? So therefore we can write this as the variance of x bar is sigma squared by n okay. Yes, you see how I got this from this to this, just using the fact that x bar has a normal distribution with mu and sigma squared by n, and similarly for y bar. Okay, so this simplifies to sigma squared divided by n plus m, right? And this clearly goes to 0 as n goes to infinity and n goes to infinity. Right, that's now. Can you guys do? You've got 4 minutes left, but can you do question 5, please? Question 3 is similar. Sorry, question 5. Yeah, not question 4. Question 4 is similar to question 2. So go to question 5. Yeah. I will. I'll put the formula sheet back on. This is the formula sheet for question 5. I think you will need to use one of these formulas. Alright, clearly for question 5 you need to use this formula here, the last one, which is the difference in proportions, right? I mean the question is talking about the difference in proportions of votes for two states, California and Colorado, right? So you need to use this formula here, the last one, right? So basically you just what you do is this: you just put in the numbers. I'm not going to do the okay. For question 5, so you have your m. Your m is 288, yeah, and your x bar is the proportion for the first sample, so it's going to be 141 out of 288, right? And your n is 216, and your y bar is the proportion, it's sample proportion for the second sample, which is 125 out of 216, right? And what you need to do is the 90% confidence interval. So 100 times 1 minus alpha is 95, meaning that alpha is 0.05, right? So your confidence interval will be x bar minus y bar minus or plus z 0.975, then in square root x bar 1 minus x bar divided by n, y bar 1 minus y bar divided by n. I mean, obviously you need to sub in so this is the 95% confidence interval for the difference in the two proportions. So you need to sub in the x bar and the y bar from this and this, and also sub in the values for m and n. Yeah. Okay. So it's not difficult, guys. But once again, the two sample confidence intervals will not be examinable for the final exam. So you don't need to worry about any of this. Right? Okay. I will go through this. And any questions on the coursework, just you can contact me before
Oh, you think it should have, but it hasn't.
But then all I'm being clear, but I haven't. The stuff for the actual fit of the distribution is quite
Yeah, I know, but once you determine the distribution, then E and F are trivial. E and F are trivial. Yeah. Did you have a question? Can I just sign and you complete the rest? Is that okay? We'll just sign here, right?
Unless you want my shoe in your plate. That smells worse than my shoe. Yeah.
Do you guys have more questions for what?
I just don't know what to do.
You've got another one to do.
Yeah, but I don't understand what you want for part D.
Right, whatever you think you want. I mean, people have already handed in their work, so I don't know.
Yeah, if I can understand what you need from part, what you want for part D, and I've written that down and I'll hand this in now. But the only problem is that I don't understand what you want for part D. Because what I've given is how I fit the distribution. So like using mu equals median t and sigma equals the mean and absolute of t minus median t. Stated what mu and sigma are, and that's it.
Yeah, that's fine. That's enough. Because let me just give me a sec. Let me pack up. Just a minute. I'll give in case. Hello, sir. How are you?
Alright, thanks.
Ask your friend to submit the coursework, right?
Yeah, I don't think he will.
Huh?
I don't think he will.
Oh. So he's gonna fail the course then?
Probably.
Huh?
You do find it an exam, I'm sure. You managed to do it last semester.
Anyway, ask him to contact. I will be here during the Easter break, so yeah, have a good time in Lithuania.
Thank you.
You're leaving tomorrow?
Big wait.
No, I'm leaving
Big
Saturday.
wait.
On Saturday.
Yeah, Saturday.
I'm going.
So, on the same flight.
Same flight. Yeah. And you sit next to each other.
Maybe, I think.
Very good.
Have a good
You too, man. You too.
Also, for the part C, it's a bit like it doesn't. I wrote at the top. It's not like very well structured because I talk about the histogram before the drawing of the histogram, just because I had to like redo it all around a different way. It's like the second histogram becomes before the first histogram, so because this one needs to be bigger than that one. So it's all in a bit of like a weird order, but it's all for the part. Is that a problem?
No, it's not. It shouldn't be a problem.
Because it's all there.
Okay, good.